Okay, we are going to talk about one more topic in this lesson. It's called compound inequalities. And there's two different types of compound inequalities we're going to deal with: the and inequalities and the or inequalities. Okay, and those are I'm going to distinguish those here in these two problems right here. So we got this situation. We want to figure out or solve 2x plus 1 is greater than or equal to 3, and 3x minus 4 is less than or equal to 17. And what we're going to do is we're going to solve those and graph the solution. So let's just start by making a little railroad track method. Oh, I don't know about yellow. Let's go back to red. Railroad track right there. Railroad track right there. We're going to solve each of these. So I'm going to subtract 1, subtract 1. So I got 2x is greater than or equal to 2. Divide by 2, divide by 2. So I got x is greater than or equal to 2. 1. Okay. And then let's do this one over here. We'll add 4, add 4. So I got 3x is less than or equal to 21. Divide by 3. And so I got x is less than or equal to 7. Now, notice I never multiplied or divided by a negative number, so I never had to swap these signs. Okay, so now that I have this, we're going to solve this. These are ands. This is an and situation. So ands mean both these have to be true to be graphed down here. So I'm going to kind of do this multi-graph thing here. Check this out. I'm going to graph this one yellow. I'm going to graph this one blue. And my final solution I'm going to make purple. Okay, so my final solution is where these two overlap on this. So we got x is greater than or equal to 1. So I'll start with a dot right up here. Oh, sorry, that should be yellow. A dot right here, and it's greater than or equal to it, so I know I go to the right. If you don't remember that, you can choose a point on either side of this. Okay, the other graph is the blue one. This is x is less than or equal to 7. So notice I don't have 7 up here. 7 up. Get it? No. So I'll put a 7 right there, and we know it is less than or equal to 7. So it's this point, and it's over here. It goes that way forever and ever, ever and ever and ever that way. Okay. Now remember, it's the overlap. So if you were to be up here, this is your face up here, looking straight down at this. Okay. It's where these two overlap. That's the actual solution. So our actual solution, I'm going to put in a pencil right here, is or in purple, not pencil, is from here to here. And it's this line in between right there. So that is the solution in purple. It's the and, it's the overlap. Okay. Now this one's a little bit different down here. This is the or one. Okay. Now let's do this one. I'll do this in. Here we go. So again, first step is just to solve this algebraically. So we'll subtract the 1, subtract the 1. So I have 5x is greater than 20. Divide by 5. So I have x is greater than 4. Greater than 4. Okay. So that's this one right here. And then over here, we'll solve this one. So subtract 2, subtract 2. So I got 3x is less than negative 3. Divide by 3 on both sides. So I have x is less than negative 1. Again, I never divided by a negative number, so I never had to swap this sign right here. Okay, now this is an or situation. Now the or's is, this doesn't have to be any overlap. It's just anywhere any function is anywhere. If you were to look from top to bottom, where do you see functions graphed? It doesn't have to be the overlap. So maybe this will explain it as I demonstrate a little bit better. Again, I'll do this one in yellow. Let's graph this. X is greater than 4, so I'll find 4. It's an open dot, right? And it's greater than that, so I know it goes that way. Okay. And then the other one is x is less than 1. We'll do that one in blue, just like before. X is less than negative 1. So I'll find negative 1. Oh, here it is. That's open dot because it's not equal to, and it's this way. Okay, so those are the two functions separately. It's not where they overlap. So really what I have is the solution here, but I'm just going to graph it in purple, the actual solution, so you can see this is what it is. This is the graph of this function right there, the or situation. Okay, so that is how you can solve and graph compound inequalities for ands and ors.